Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at how to debug your code. In our last video on debugging, we looked at 4 different areas. We looked first of all at compile time errors, then logging and the use of the function name command. Next, we looked at the call stack and how to use it. And finally, we looked at the use of the profile command. In today's video, we will look at 2 additional ways to debug. Firstly, we will look at the trace command to generate a trace file. And finally, we will look at the debug facilities of the PowerBasic IDE to compile and debug your application. So within the PB main function, we're going to call a new function called start process. This will be the first function in a series of functions to demonstrate the use of the trace command. So here is our new function, start process. We have declared 2 local variables, one called value and one called loop. Both of these are long variables. We've also assigned 100 to the value variable. Next, we're going to use the trace command. So within this process, we can first of all define the name of the file we wish to write to with these trace commands. And we can do that using the trace new command, followed by the path and name of the file. Since we're giving no path here, the file will be created within the same folder as the current executable. Next, as we did in the last video, we're going to use our logging command to display on screen the name of the function we are currently executing. Next, we're going to use our loop command to loop around a for next loop from the value 1 to the value 10. Within this loop, we're going to call a second process function, passing it 2 values, the value variable and the loop variable. And after that loop has completed, we're going to exit the function. So let's go create this second function, and then we can put some trace commands in. So here is our second process function taking its 2 parameters, and it's declaring a local variable, and then printing out the name of the function to the log. So if we try a test compiling that to ensure it compiles cleanly, which it does, and we attempt to run our application. So our application prints out the start process function name, and then it pushes out the second process 10 times, as we're in a loop from 1 to the value 10. So our application is working as expected. However, within your applications, you may need to do some tracing to figure out what's going wrong, and this is where the trace command comes in. So we have first of all only defined the name of the trace file that's going to be written to. Now we have to turn the trace on. And we can do that quite easily by using the trace on command. And once we no longer need to trace any information, we can then turn off the tracing and close down the trace file. So let's see what these trace commands actually give us. So now that we have compiled our executable, let's try running it and see what we get. So there is our application running, and we're calling the second process function 10 times. If we look in the folder, we can see we now have a tracefile.txt. If we open that up and compare that to the code, we can see the first call to our logging routine passing it a parameter of start process, which is the name of the function. It then details that we have exited from that function, and we're now calling the first call to second process. And it is also reported the value of both parameters. Within that second process function, we're calling our logging function again, and then exiting the logging function. So it's reporting nested processes as well. So we can see the call to each of these subsequent second process functions and the values that were passed to that function. So it's giving us quite a neat audit trail of the processing of the entire application. If you have nested processes like this, it can create a rather large file. But what we can do to limit the size of our file is to use the trace off command. So we could put a trace off before the call to our logging in the second process function. If we ran that now, it would still run as before. If we looked inside the trace file, we would see we're only getting the call to the first second process function, as within second process we've turned tracing off. However, what we can do is we can turn tracing on before we call second process. If we run that now, and then we'll look at our file, we can see the call to each of these subsequent second process functions and their values. So using this approach of turning trace on and trace off at critical points in your application, you can limit the amount of information that's sent to the log when each of the functions is actually called. Additionally, you can use the trace print command to print specific information to the log. For example, we can turn the trace back on, use the trace print command to print the details of the value variable out to our trace log, and then turn trace back off again. If we try running this now, and go back to our log, we can now see we're getting the trace beginning, we're getting the first call to second process with its subsequent parameters, and we're getting the details of the value variable for each of the calls to second process. So using trace print means you can get specific information from each of the functions we want to call. If we added a third process to the mix, for example a for next loop within our second process to call a third process. And here is the third process with its single parameter. And in here we're doing another for next loop. If we run this as is, as you'll see from our screen, it's taking longer to process, as our trace command is actually operational. Any debugging like this will slow your application down, and you would normally only use these trace commands when you're trying to find a problem with your application, perhaps a value that is being incorrectly set somewhere within one of your functions or subroutines. So if we have a look at our log now, we'll see it's still reporting the first and second processes, but not the third. This is because we don't have logging turned on. If you wanted to have our tracing turned on, we'll just move where the trace off command appears. We can take it out of here and put it after the call to our third process. And if we run the application now, it will become even slower because we're now tracing the third process as well. So once this is completed, we'll then have a look at our log once more. And as we can see, the log has indeed got larger. So there is the call to our second process. And here are the calls for 5 attempts at calling the third process. And then the same for each subsequent call to the second process. So you can see from this, the size of the log can get considerably larger if there are a lot of nested calls. But you can turn the log on or off using the trace on and trace off commands. And anytime you need to look at the particular values at any point in your code, you can use the trace print command. This is ideal when you're doing some debugging of the application. If you then go back to the beginning of your code and comment back in the tools off command. And with the tools command off, if we run the application once more, we will see there is no trace command text file being created on the disk. So using the tools off command will deactivate any trace commands within your code. But ideally, before you release your code to the production environment, you will remove all your trace commands. So the trace command can be useful when you're trying to track down a particular problem. However, you can go one stage further and use the full debug facilities of PowerBasic. In this case, it's the bug icon on the toolbar. If we click on this, we will be compiling and debugging the current application. So as soon as it does this, you'll see you've got a new IDE at the top of the screen. We have a variable watcher window, which will remember the last set of variables we were looking at. So we will clear all our watches for the moment and go back to the main code window. So in here we have one line of text which is highlighted in yellow. This is the line of code that PowerBasic is about to execute. You can look at the toolbar buttons at the top. We have a register watcher which looks at the registers of the CPU. We have a variable watcher which is this variable watcher window on the right. To exit, we have a large X toolbar button which will exit debug mode. And we have 3 box icons at the top of the toolbar. One for stepping over the call, one for stepping into the code, and one for stepping out of the code. If you look at the debug window, you'll see that these have got keyboard shortcuts: F8, Shift F8, and Shift Control F8. And there is an additional one to toggle a breakpoint, which we will do shortly. So we're just going to be using the step into one at the moment, so the F8. So if we hit the F8 function button, it moves down to the next line of code. This function here may not be the one you wish to debug. So you want to execute it, but you don't want to go in to look at every single line of code within this function. So in this case, what we will do is to step over this one. And that's Shift F8. Now it has executed that particular function, but it hasn't gone into debug mode within that function. So if we go down until we get to start process by using Shift F8. And if we hit the F8 on its own, it will go into the start process function. And now we can go down here. Now if we want to look at what value is in this value variable, if we double click and right click, we can then watch the variable. And it adds it to the list of variables we're currently watching. So we can see that the value variable currently holds a value of 0. This next line of code should change that value to 100. So if we hit the F8 button once more, we'll see it now has the value of 100. So using this approach, you can add on variables to this list of watched variables, and you can see when they actually change value. So let's go down until we get to this loop variable. So we can double click on it, right click, and add it to our watch list. It has a value of 0 as we have not yet populated it. So if we hit the F8 button, we can go down to the next line of code. If you wish to skip through a whole series of lines of code which you're not interested in, for example, we're only interested in this line of code, you can go to that line of code and press the F9 button. The F9 button is where we have toggled a breakpoint. So now that we have a breakpoint set, we can use the Run or the F5 button to go to that line of code. So it will run each line of code between where it was and the breakpoint. So it saves pressing F8 a great deal if there are a large number of lines of code you wish to execute but not look at. So now if we hit the F8 button to go down to the next line of code, we can see the value in our loop variable is now the value 1. You can also right click on the variable and go into Evaluate. As you can see, we have just changed the value of the loop variable. It now has a value of 2. So if we go down another line of code and go into our second process, we can see it still has a value of 2. So right-clicking on a variable, evaluating it, and then amending it within this section here to modify the variable will allow you to change the value of a variable. This can be useful if you want to simulate some particular action within your application. And again, F8 can be used to step through these, and Shift F8 can be used to execute that function, but not step into it. And then we get down to our third process, and it will pop into there. So as you can see, the debug function is very useful when you're looking at specific lines of code within functions. You can set breakpoints to skip over all the code that comes before that. However, be aware that your application will run much slower in debug mode than it runs normally. If we look at the animate function, if we click on animate, it will step through lines of code one line at a time. So you can watch your application and see exactly what it's doing. And the stop program will stop your program in its tracks, and it will remain on that line of code that's highlighted in yellow, and you can manually step forward. It's also useful to set a breakpoint when you're animating. If we animate that, it will step through these lines of code and stop on the breakpoint. And if we wish to exit, we can click the large Exit Debug Mode button. It's important to note that having been in debug, if you go back to the folder containing your code, there is no executable. If we run the application in debug mode once more and have a look at the folder, we will see that there is an exe in here, but it has an additional file, this exe.pbd. This is PowerBasic Debug Mode. So the exe in here is not a true executable. It's a debug executable, and these will be deleted when you exit the debug mode. We exit, we'll see that those files are deleted. So having been in debug, if you want to get your executable file back, you need to go back in and compile it normally. And at that point, your exe will return. So in summary, what we've looked at today are two additional ways for debugging your applications. We've looked at the trace command to generate a trace file, and using the trace on and trace off commands to turn on and off tracing when you need it. You can additionally use the trace print command to print specific information out to your trace log. If you have a look at the help file for the trace command, you will see that the trace command is thread aware. So if you're using threads within your application, you can use each thread having its own individual trace file. This would ensure that information from one thread will not pop into the trace file of another. And the second thing we looked at today was the compile and debug function of the PowerBasic IDE. This allows you to set breakpoints within your application and or step individually through single lines of code. You can view the value of variables, put them into a watcher list, and even amend the value of variables themselves. This gives you complete control of what's happening within your application to try and trace where problems are occurring. Hopefully you'll find these commands useful when debugging your applications, but that's it for today. Thank you for watching.